Hi guys, now in this video I will demonstrate how to compare your data against theoretical normal distribution statistics and properties, I should say, and then make a decision whether your data is normally distributed or not. So for that I need summary statistics of my data. So you'll have to calculate this. So you'll have to calculate this different statistics. First, the mean formula is, as you can see, usual average. Standard deviation formula is again STT formula. Max formula is maximum. Now the data here, by the way, quickly is the returns in 2009 that we used in the class to CEO compensation regression. Remember? So this is the data. And this minimum is just the minimum value of the return in the data, and first quartile is just the 25th percentile, so you use this formula quartile, the range, comma 1, so double click here and you will see that the range is the returns, and do not highlight the name here, and then 1 actually tells us to get the lower quartile basically, and this one is the 3, so it's the third quartile here, the same range. Now interquartile range, as you know, is the difference between third and then first quartile. So 43 minus 1 gives me the interquartile range. And range is the difference between maximum and then the minimum of returns. Now, what I will now do is use these rules. The first rule of normality is that interquartile range should be equal to 1.33 times standard deviation of my data distribution. So if this equality holds in my data, then it's one evidence that my data is normally distributed. We can check that now. So interquartile range is here. I will now calculate this one here, this value 1.33, so equal 1.33 times standard deviation, so it's this value right here, equal. Well, as you can see, 42 is not equal to 71.5, so we can say no. The first evidence says it's not normally distributed. Our data returns are not normally distributed. Second rule is that the range is actually, range of our data should be equal to 6 times the standard deviation of the data distribution. So let's have a look at that as well. So 6 times standard deviation equal. Well, it also tells me that no, it's not. So as you can see, this doesn't hold. I mean, normality assumption doesn't apply on our data, so it is not normally distributed. But we can check further by using the empirical rule, according to which 68.3% of the data will lie within plus minus one standard deviation of the mean. So it's plus minus. I don't put it because I didn't have plus minus sign here in the Excel, a symbol I should say, and or 95.5% of the data should lie within 2 standard deviation of the mean. So I just do 95% approximately. So let's test for this now. To do this, what I do is I will find the value that lies 1 standard deviation below the mean, and I find another value that lies 1 standard deviation above the mean, and then I count the values between these two numbers, and then I divide so I count the numbers here of the values that are between these two numbers, and then I divide this number by the total observations to see if it's equal to 68% or not. So let's do that. So to find the value that is 1 standard deviation below the mean, you just use the usual formula, which is mean minus 1 standard deviation below the mean. So that's 1 standard deviation. Mean minus 1 standard deviation equal. So that's a negative return. Some value here, somewhere here is that lies 1 standard deviation below the mean. Next. Now, next value is 1 standard deviation above the mean. So that's mean plus standard deviation. This is the 1 standard deviation above the mean value. So it lies 1 standard deviation above the mean. Now, I need to count the number of observations. Now, obviously, you could sort here the data and then locate this value and locate this value and then count the number of observations between these two to see if they are 68% of the data. So, but I will use the easier way, that is using the count if function. So first of all, I will count all the values that are above minus 25, and then I count all the values that are above 82, and then I minus these two values, and it gives me then number of observations that lie between these two values. Right, so let's see. So let's start with this data here. Count if, open a bracket. So this is a count if function. Now we need to give the range here. The range is that runs from this down to the bottom, 198 apparently, and so this is the same range as we used here. Now I have to use a slightly different version of coding here for criteria. Criteria is that I need to count all the numbers that are bigger than this value. So this would be in the quotation marks, greater or equal, let's say, than minus 25 point, let's say, 2, and we'll close the quotation marks, and also close the bracket. Let's see if it works. Yeah, it turns out there are 184 observations that are greater than minus 25% return. But now, because we want to count the difference between 1 plus minus 1 standard deviation of the mean, observations between these values, then I'll just double click back, and I minus from this the number of observations that are above 82% now. So let's do count if again. Count if, the range is the same, A2 to A198, and in the quotation marks, within quotation marks, they are greater or equal to 82.39, so 82.4 maybe, 2.4. well, it won't be that precise, but let's see. Okay, I forgot to do something there. I forgot to close my quotation mark. So luckily Excel saved all this that I entered already. Done. So it turns out that 166 observations lie within these two values, basically within two returns. Now, what is the total observation? So, well, that is easy to find. So let me first copy the range, this range. So we will count now total observations. So count, now it's a normal count within this range. Okay, there are double brackets. So there are 197 observations, of which 166 lie between these two numbers. Now I need to calculate now the proportion, or I need to find out what percentage of these 166 observations are of 197 basically. So let's call proportion. If this proportion is equal to 68%, then our data is normally distributed. But let's see how it goes. So 166 over 197 equal. No, it looks like it's 84% actually. So it's way above. So we have more concentration of the data within one standard deviation of the mean here in our data instead of 68. So we can say this is not normally distributed data. Now, another thing to look at is how about two standard deviations of the mean? How many data points lie? Well, what I can do is I can actually calculate that as well, and then see if the value of proportions will be 95%. Rather than doing another calculation, I'll just change this to two standard deviations. So let's go, and we know that D3 is our standard deviation, so I'll just multiply D3 by 2. So I subtract from mean a 2 standard deviation value, and from this value I'll multiply the standard deviation by 2. So this will be mean plus 2 standard deviation two standard deviation, sorry. So this gives me then a value 2 standard deviation above the mean, and this is the value 2 standard deviations below the mean. And now I can do count if again, and I can change this lower value to minus 79.03. The value on the upper side is now 136.21. Yeah, you can actually do cell referencing, but it's another formula there. I'd choose easier for you. So enter. Well, it looks like we have 190 observations that are within 2 standard deviations of the mean. Well, it's if you divide it by the 197 observation, which is the total observation, you have 96%, a fairly normal distribution, isn't it? Looks like. So, however, it will be well. You can say that it also almost confirms to the second what is this second rule of empirical rule. This is first rule, second rule, but then we can test the third rule, which is actually fifth in this case, that the 99% of observations or data lie within the 3 standard deviations of the mean. So why not try that? So let's times this by 3. Let's also times this by 3 and then see if that's true. And I will have to change this now. Minus 132.84, and this would be now 190.2, sorry, 02. So yeah, 98%. So it's smaller than 99%. So let me type it fully. So of data is within 3 standard deviation of the mean. Right, so we only approached more or less, our data is more or less confirming to this one of the rules, but all of those rules are different from, almost, I would say, one notch. So when you look at it from a broader perspective, or by looking at whole data, it looks like it's more like a normal distribution, but in fact it must be skewed data. We can actually check that by doing a box plot, or let's look at the median as well. Oops, median. And our other rules, like these rules here, theoretical counterpart rules, do not confirm that. So let's do a median analysis as well, median analysis. So median, open a bracket, paste the range. If they are equal, I mean, if my mean and medians are equal, I would say they are, the values are normally distributed. But let's see. Oops. So they are not actually equal, so the data is skewed, so it's not normally distributed. This is one other way of testing it, and you can use the you can use box plots basically to test that as well. Right? So that's basically it. So I hope this will help you to complete your homework. I think, and also you can add the 6th kind of rule here. I think your book has some more rules that we could use here if you wish to. But then I think this is enough now, just for you to start doing your own calculations and adding any rules and then testing for any of them. Yeah, hope this helps then, and see you in the next video.